Welcome to Computer Networks.
Hi, hello everyone. In this video, we will discuss on high level data link control, that is HDLC, by myself. Now we can discussing it. What is HDLC? HDLC is a high level data link control, and it is a bit oriented protocol for communication via point-to-point and multi-point links. We know point-to-point is a dedicated link in between two devices, and coming to the multi-point indicates we can transfer our data to multiple devices in a same network. Okay, in this topic, we have discussed configurations and transfer modes and frames, and next one, control fields. Okay, let us discuss one by one. The first one, configurations and transfer modes. Now discuss the first one, configurations. What is configurations? What is the purpose of configuration? Which devices are used to configure our network? Here this protocol HDLC specifies the following three types of stations for data link control. The stations are primary station, secondary station, and combined station. Now you can see what is the purpose of primary station, what is the purpose of secondary station, what is the purpose and functionality of combined station. Okay, let us discuss one by one. The first one, primary station. Primary station, it indicates the controlling station on the link. Okay, where link indicates the network. A primary station, it is used as the controlling another station on the link. Okay, here it is the responsibility of controlling all the other stations on the common link. Okay, that remaining stations are, you can call as the secondary stations. Okay, the primary station's main responsibility controlling the secondary stations in the network. Okay, here the purpose of the primary station is the primary station sends the commands, and the secondary station, it accepts the commands and it gives the particular responses. Secondary station. The secondary station is under the control of the primary station. We know the secondary station is always controlling the primary station. It has no ability or direct responsibility for controlling the link. Okay, always monitored by primary station. It is only activated when requested by the primary station. Okay, whenever you can receive the request from the primary station, particular command, the secondary station only activated. Now you can see the combined station. A combined station is a combination of both primary and secondary station. Okay, what are the functionality by primary station, what are the functionality by secondary station? These two functionalities are combined at this station. A combined station is a combination of primary and secondary station. Okay, in the network, all combined stations are equal priorities. Okay, at the same time, it receives the commands and also it sends the responses to the other stations. Okay, and also these receiving and sending commands without any permission from the another stations. Okay, so on the network, all the combined stations are able to send and receive commands and responses without any permission from the other stations in the network. Now you can see the next one, transfer modes. Here the HDLC, high level data link control, provides the two common transfer modes that can be used in a different configurations. Okay, in the previous slides you can you can learn different configurations, primary station, secondary station, and combined stations. So by using these stations to configure by applying the different transfer modes, but here they are using the two types of transfer modes. The first one is the normal response mode NRM, and second one asynchronous balanced mode ABM. Okay, by using these two modes to configure to transfer our data from one device to another device. Okay. Now let us discuss one by one. The first one is the normal response mode, NRM. In normal response mode, the station configuration is unbalanced. Okay, the station configuration is unbalanced. Okay, because the primary in the NRM used for both point-to-point and multi-point links. Okay, you are using the NRM, normal response mode, used to both point-to-point and multi-point links. And also, you can configure the normal response mode. We have one primary station and remaining stations are secondary stations. Okay, the remaining stations are secondary stations. Okay, in a normal response mode, the primary station and secondary station. These two stations are in a network. Okay, what is the purpose of primary station? The primary station always sends the commands to the secondary station. It receives the commands by the secondary station. It gives the particular response to the primary station. Okay, you know it is the point-to-point link. And coming to the multi-point link, in a multi-point link, okay, one is the primary station, remaining all stations are secondary stations. Okay, the primary station always sends the commands to the secondary stations. The secondary stations are, it gives the particular responses to the primary station. Okay, it is the multi-point. Okay, next type, transfer mode, asynchronous balanced mode. Okay, in ABM, in asynchronous balanced mode, the configuration is balanced. In NRM, the balance is unbalanced. The configuration is unbalanced. Here, in ABM, the configuration is balanced. Okay, and also it is only for point-to-point connection. There is no any multi-point connection. The link is, okay, in asynchronous balanced mode, the network link is point-to-point, and each station can function as a primary and secondary. Okay, so it is the combined station. Okay, each and every station is act as a combined station, where combined station indicates the both primary and secondary. For example, a combined station, okay, it sends the commands and also it sends the responses. Okay, anything. Okay, sending from each and every equal priority in a network. Okay, right? Now we can discussing the next concept in the next topic in the HDLC frames. Okay, to provide the flexibility necessary to support all the options possible in the modes and the configurations just described. Okay, here the HDLC defines the three types of frames. Okay, the first one is the information frames. Okay, the information frames always sends control information or user data. Okay, the iframes are used to transport user data and control information relating to the user data. And always using the piggybacking concept. Okay, next one, supervisory frames. Okay, S frames. The S frames are used to only transport control information. And coming to the next one, unnumbered frames, U frames. The U frames are reserved for system management. Information carried by U frames is intended for managing the link itself. Okay. Right, now you can see the frame format of HDLC. Okay, in a HDLC you are discussing the three types of frames, I frame, U frame and S frame. Okay, now the frame format, each and every frame in HDLC may contain the up to 6 fields. Okay, for example, I frame having the 6 fields and S frame having some more less than 6 fields. Okay, let us discuss one by one each and every frame format in a HDLC. Okay, this is the diagram belongs to the HDLC frames, belongs to the I frame and S frame and U frame. Okay, the frame direction is from starting to ending. Okay, here using the total up to six fields. Okay, either flag field, address field, control field, user information, FCS, that is the frame check sequence. Okay, and also I frame up to 6 fields, including the both flags. And coming to the S frame, Okay, flag, address, control, FCS and flag. This is the total 5 fields. Okay, and coming to the U frame. Okay, U frame also contains up to 6 fields. Okay, both including the flag fields. Okay, let us discuss one by one each and every frame in detail. Okay, and initially we can discussing the here fields. Okay, how many fields here? Total up to 6 fields. Okay, the first one is the flag field. Okay, the flag field of an HDLC frame is an 8-bit sequence with a bit pattern, that is the 0, 6 ones 0, that identifies the both beginning and end of the frame and serves as a synchronization pattern of the receiver. Okay, a flag field, the total size is 8-bit. It indicates the 0, 6 ones 0. Okay, and also these complete address we have to indicate in the beginning and ending of the each and every frame. Okay, next one, address field. The second field of an HDLC frame contains the address of the secondary station. Okay, address of the secondary station. If a primary station created the frame, it contains the 2 address. Okay, if a primary station create the frame, it contains a 2 address. If a secondary station it creates the frame, it contains the from address. So it is the address of secondary station. An address field can be identified up to identify up to 120 stations, and also the address maintained here 1 byte or several bytes long depending on the network. Depends upon the network need. Okay, if the address field is either 1 byte or several bytes depending upon the needs of the network. Okay, and also each and every 1 byte identifies the up to 128 stations. So, in the larger networks, they require multiple byte address fields. Okay, if the address field is only 1 byte, the last bit is always a 1. Okay, the last bit always a 1. If the address is more than 1 byte, all bytes, but the last one will end with 0. Only the last bit and last byte will end with 1. Ending each intermediate byte with 0 indicates to the receiver that there are more address bytes to come. Next one, control field. Okay, the control field, the address is 1 or 2 byte segment of the frame used for the flow and error control. And next one, information field. The information field contains the user's data from the network layer or management information. The information field, it contains the user data or management information. And the final, the FCS field, where FCS field indicates the frame check sequence, is the HDLC error detection field. Okay, it contains a 2 or 4 byte field. That is the frame check sequence. FCS is the HDLC error detection field. It can contain either 2 or 4 byte. Okay, let us discuss with the next topic in the HDLC, control field. Okay, and also the control field is common for each and every frame, I frame, S frame and U frame. Okay, right. The control field defines and determines the type of frame and its functionality. By using this field, the control field, okay, you can clearly determine or define this belongs to which type of frame and its functionality. Okay. Now you can see the control field format for the different frame formats. Okay, we know the control field, the size is 1 byte. Okay, now 1 byte or 2 bytes, but we will take here 1 byte. Okay, it is the 8 bits. 1 byte for I frame, 1 byte for S frame, 1 byte for U frame. Okay, and also by using this frame, you can easily identify that frame format belongs to which type of frame, either I frame, S frame and U frame. Let us discuss one by one. The first one, control field for I frame. Okay, we know the I frame purpose is only it carries the user data. Okay, and also they can include the flow and error control information piggybacking. Okay, the always iframes, it includes the flow and error control information piggybacking. Okay, now let us discuss the subfields in the control field are used to define these functions. Okay, the subfields in the control field are used to define these functions. The subfields indicate that the total 8 bits. The total 8 bits, it defines these functions. Okay, right. The first one is the format for the iframe control field. Okay, 0, 3 bits NFS and P by F, and the last 3 bits NFR. Okay, iframe. Whenever you can observe here, the first bit defines the type. If the first bit of the control field is 0, this means the frame is iframe. The next 3 bits called NFS, where NFS indicates the sequence number of the sender side. Okay, you can assign the sequence number and rearrange the total frames in a sequence order at the receiver side. The next 3 bits called NFS define the sequence number of the frame, and the sequence number, the range is between 0 and 7. And the last 3 bits called NFR, where NFR indicates the acknowledgement number when piggybacking used. The last 3 bits called NFR. Okay, receiver side, it sends the acknowledgement to the sender. Okay, and also you can sending our data at the time you are using the piggybacking concept. Okay, the single bit between NFS and NFR is called the P by F bit. Okay, where P indicates the pole and F indicates the final. Okay, the P by F field is a single bit with a dual purpose. Okay, here the single bit indicates the 1 bit. Okay, either 1 or 0, but it uses the dual purpose. It has meaning only 1 bit. It is set to bit equal to 1. Okay, but you can include the 0, there is no any meaning. Okay, you can include the only 1 bit, that is the 1. That time there is some meaning purpose. Okay, that can either pole or final. For example, pole means the frame is sent by primary datation to the secondary. Okay, where pole indicates that frame is sent by primary datation to a secondary. Final means the frame is sent by secondary to a primary. Okay, where pole indicates primary to secondary. Final indicates the secondary to primary. Okay. Next one, control field for S frame. Okay. We know the S frames do not have the information fields, but it sends only control information. Okay, if the first 2 bits of the control field is 1, 0, this means the frame is an S frame. The last 3 bits called NFR corresponds to the acknowledgement number ACK or negative acknowledgement number NAK, depending on the type of the S frame. Okay, the last 3 bits called NFR corresponds to the acknowledgement number ACK or NAK, depending on the type of the S frame. You can observe here the first 2 bits are control field 1, 0. Okay, and the last 3 bits called NFR, where NFR is using the acknowledgement number, sending the receiver side. Okay, and also where that is the ACK number or NAK number, depends upon the S frame type. Okay, now and also you can see the P by F. Okay, what is the purpose in the iframe? P by F purpose is same as it is stated in the control field for S frame. Okay, what are the purpose in the control field iframe? The same purpose are using at control field for S frame. Okay, now let us discuss. You can see the 2 bits in code. The 2 bits called code is to define the type of S frame itself. With the 2 bits, you can have 4 types of combinations. With the 2 bits, we have the 4 types of combinations of S frame. Okay, the first one, receive ready RR. Second one, receive not ready RNR. Reject REJ. Selective reject SREJ. Okay, let us discuss the 4 types of frames one by one. Receive ready. If the value of the code is subfield 00, okay, you can include the code type is 00. It is an RR. Okay, where RR indicates the receive ready of S frame. Okay, this kind of frame acknowledge the receipt of a safe and sound frame of or group of frames. Okay, whenever you can include the 00 subfield in a code, okay, we can transmit our data is successful without damage or without loss. Okay, we can happy. Receive not ready, RNR. Okay, where RNR indicates the subfield is 10, it is an RNR S frame. It acknowledges the receipt of frame or group of frames. It announces that receiver is busy, cannot receive the more frames. Okay, whenever you can include the 10, the receiver is busy, okay, for processing the different frames. So, in this time, the receiver cannot receive more frames, so you can slow down the process. And coming to the reject, RAJ. If the value of the code subfield is 01, it is RAJ's S frame. Okay. The purpose of RAJ is, it is a NAK frame, negative acknowledgement frame, but not like you are using the selective repeat ARQ. Okay, this NAK frame, you are using the go back N ARQ to improve the efficiency of the process. So, this NAK you are using go back N, not in selective repeat. Okay. Next one, selective reject, SRJ. Okay, this is the NAK frame used to selective repeat ARK, and also you can use the subfield is 11. Okay, this NAK used as selective repeat ARK. Okay, above NAK used at go back in ARK, but this NAK used at selective repeat ARK. But it is a negative acknowledgement number. Okay, next one, control field for U frame. Okay, that is the U indicates the unnumbered frames are used to exchange the session management, the control information, that is system information or system management information. And also U frames contain information field, but one used for the system management and the information, but not user data, we know. Okay, that is the, you can clearly identify the first two bits are 11. Okay, this belongs to the U frame. Okay, and also you are using the P by F, the same purpose or P by F you are in the I frame. Okay, don't worry about that. Okay, code, first, the left side P by F, 2 bits of code, and right side of the P by F, you are using the 3 bits of code. Okay, U-frames codes are divided into 2 sections. Okay, 2-bit prefix before the P by F bit and 3-bit suffix after the P by F bit. Okay, you can observe here. But by using combining these two sections, these 2 segments, total 5 bits, can be used to create up to the 32 different types of U-frames. For example, you are using some sample codes, combinations of code 00, 001. Command, you are using the SNRM. That is the response indicates the set normal response mode. Okay, 11011. SNRE, SNRME. Set normal response mode executed. Sorry, extended. 11100. SABM. Okay, set asynchronous balanced mode for disconnect mode. Okay, these are the different combinations. Thank you for watching this video.